Okay. So for those of you who have the lab document open, we'll go over lab 2 and 3 today. For lab 2, we're still having some technical issues getting Team Center Engineering working. And so we are going to use an application called Dropbox instead. I don't know if some of you are familiar or not with it. It's similar to Team Center Community in that you can upload files from your computer to a web-based database, and you can share a folder with other team members, and so that way it's a great tool for collaborating if you're not here on campus, or if you are here on campus, or if you have members of your team that are at a different school. So we'll go through Dropbox in just a minute, but Eric's going to show you guys some really cool stuff about HyperMesh, since you guys will have another tutorial, so I'll just kind of let him show you that real quick.
Is anyone on Skype that wants to listen in, or they intend?
Is there anybody on Skype at all, or?
We have one person yet, Alex J.
Does he want to listen in? Should we?
Can he hear us on the Tandberg? If not, we can Skype.
If he adds Josh and calls him, then we could you could just listen in.
So you want him to add you as friends in Skype?
Yeah. If he wants to talk on Skype. If he has the Tandberg up and he can hear us, either one of those is fine.
I'm just going to get started. So we know that HyperMesh and stuff isn't the most user-friendly program. We took the class, but it is. I've been really amazed at what HyperMesh can do. So we hope to I'm just going to show you just for like 2 or 3 minutes one thing that we're going to be doing using HyperMesh for in this class, which I think is really, really awesome. I even got an internship at Altair, who makes HyperMesh, and worked with it the whole summer, and we did some really cool stuff with it. So just a quick, here's a video that is of one of the tutorials in HyperMesh, and talks about topology optimization. Now, Dr. Jentz is going to go over this in a couple weeks or so, but as you can see, this is a part like the leading edge of a wing, and they want to make the lightest structure possible within this space. So they have the different loads and constraints and everything on this model. And what OptiStruct does, OptiStruct is an optimization solver within the HyperWorks suite after you mesh something in HyperMesh, is it will find where the load paths are according to the loads and everything. And so the optimal design would have beams going through here. And then once you find that topology where the loads are, then you can do another optimization of how thick should they be and stuff. Another example that I did over the summer that we'll probably make into a video and put on the website just as a tutorial, just to kind of show how to set up an optimization, is this. Now I just made this simple block. I think it's 5 inches by 10 inches by 20 inches, and it's constrained at the bottom. That's what these triangles are. And then at the top is a load. So basically I'm making a bridge here, and I wanted to make, and I only allowed the program to keep, I think 25 or 30% of the original material, of the green material. It has to eat away what it can of the green material. So after 23 iterations, this is what it came up with, and this is the result when I set the bar to a certain value.
Real quick, for those who joined us on the Tandberg, if you guys could mute your mics so we don't get any feedback, we'd appreciate it. If you have questions, please turn on your mic and we can answer your questions.
Thanks. So the optimal design for this situation is this bridge, and I think it's remarkable to see how it looks exactly like a modern day bridge. And I'm a nerd saying this, but look, it's even a parabolic arc, and it didn't even know to find that. So OptiStruct does some really cool stuff. My boss at Altair even said that he's heard of design competitions they have at schools of, like, balsa wood bridges or stuff like that, and they outlaw the use of this software because it works so well that you can do whatever you want with it. So we're going to use this stuff to we're going to redesign some of the parts in your car, or you are going to redesign some of the parts. You're going to find a part and you're going to make it better. You're going to find if there's a better load path to have the part. You're going to optimize these different parts. So yes, HyperMesh is kind of a pain to learn, but it's really, really cool. So
does it take into account the material type that you use? 'Cause I mean,
Yes.
That,
Yeah.
Every material has its own modulus of elasticity,
Right.
and it takes that into account.
Yeah. In this case, I
These
just did aluminum.
Yeah,
just
these
for
are
simplicity.
realistic stress analyses for different types of materials, and depending on the loads you place on them.
All right, so that's just hopefully that helps you just appreciate hypermesh a little more and have a greater desire to learn it because it's
Yeah.
really
If
cool.
I remember correctly, on the F-22 Raptor, they were trying to make it more lightweight, and so they used this software on almost all of the parts to reduce the weight. I mean, they found ways to make screws smaller. They found ways to, change the wing structure, everything, and they were able to reduce the weight by, I think, about 70%.
Yeah.
So.
Doc-
so this is a pretty simple structure. How long would it take hypermesh to run it and reduce it?
To solve,
Yeah.
this one took, actually, because this one was, I only did, these are 1/2 inch blocks, 1/2 inch by 1/2 inch, because it's 5 inches long. This one only took about, I think like 10, 15 minutes to run on my slow computer at work. Like it was not too long. If I made the element size twice as small, then it would mean there's 8 elements for every one of these, and then it multiplied it by, it got to be like several hours.
Really?
So it also is another example of the mesh size. The bigger the mesh size, the faster it's going to run, but at the same time, the smaller the mesh size, the more accurate your result's going to be. So, and we'll talk about that later. A quick thing to keep in mind is that the OptiStruct will run way faster on the Linux machines for the BYU students up in the Catum lab. We would suggest when you get to those, you can do your hypermesh, like mesh your object in on Windows. That's fine, and then just save your file and bring it over to the Linux machine and run the OptiStruct optimization there because it'll run like way faster. So yeah.
Okay. All right, so we're going to go through the individual assignments. We'll start with Lab 2. So today, Lab 0 is due, so if you guys have that, you should turn that in to me. Just put it here on the table.
Or upload it.
Or upload it if that's what it asks you to do.
Why did you call it Lab 0 and not Lab 1? I'm confused.
Because this is like a well, I don't know. I think Dr. Jensen just likes to start all of the labs at 0 just because.
But wasn't it called Lab 1?
I think it was called Lab 1.
Oh, was it Lab 1?
Yeah, it
Oh,
was
I'm
Lab
thinking
1.
of
It was
another
wrong.
class. I'm thinking of 172. I'm sorry. It was Lab 1. Sorry. No, Lab 1 is due today. We're going to go over Lab 2 and Lab 3 today. They will be due next time in lab, and next time we will be going over Lab 4, which is what we discussed in lecture yesterday.
Right, can I say something? We've tried to simplify another thing from this lab from last week. First of all, like when it has the checklist of what is due, we've tried to put, on every time we've put whether it's an individual submission or a group submission. So hopefully that clarifies, because we had a lot of questions about that and I realized we could be a little more clear. So if it says group submission, you turn it in as a group. If it says individual, you do it yourself. And also, to simplify things, we're just going to make everything, the in-class exercises are not due at the end of class. We'll just make everything due next time. So both in-class exercises and homework for both Lab 2 and 3 will be due by the beginning of lab next Friday. Okay?
Cool.
Okay.
All right, so for Lab 2, the in-class exercise, each student is to do or participate in the following. You're going to hold a Skype team conference. You will discuss who will build which of the following parts. There's a cylinder, an extruded rectangle, a sphere, and a cone. You're going to model each of those parts. And then there's also a base. You will then have each team member who modeled their part check it into Dropbox. So I will show you guys how to use Dropbox in just a minute. You'll need to create a shared group folder. And then you're using join.me and Skype, take turns adding your parts to the team's overall assembly, and you will save the assembly model in Dropbox as well. And then when you're done with that, you can access a remote team member's part if you've got a remote team member. If not, you guys can do the same thing with the BYU team here. And you will modify those parts. So you'll take turn modifying those parts. You will save the part as a new version. Dropbox automatically does version control for you, so I can kind of show you how it does that. And then using join.me and Skype, access your team's assembly model, update the assembly, and notice the modifications that were made to each part. you will save the assembly model as a new version to Dropbox, and the list of submissions for this is just to complete the lab exercise. So there's not going to be anything that the TAs are going to be checking on this. We just want to make sure you guys are familiar with the tools so that you can use that. So I'm going to hop onto the web real quick, and I'll show you a quick tutorial about Dropbox. We'll cover the homework, and then we will move on to Lab 3. So Dropbox is pretty easy to use. If you just hop onto the internet,
Yeah.
Yeah.
So Dr. Jensen was telling me.
if you hop onto the internet, Dropbox.com is where you'll go to, and you can download Dropbox to your individual computers at home if you've got a laptop. Unfortunately, we can't download Dropbox to the CATM computers, but you still can access parts through the website. So if you just log in, you can either create your own account, which is what I'll have you guys do. I've already got an account set up, so I'll just kind of show you the process for once you've actually been able to create your account. See if I can remember my password. Okay, so it's basically an online database. You can access it anywhere if you just log on to the internet and type in your password. If you download it, anything you put in your downloaded folder on your personal computer will automatically be updated or uploaded to the internet site. Every Dropbox account has its own set of memory. You've got 2 gigs set up for you. And if you wanted to create a new folder, you can just do new folder. You can call it, Catia is awesome, if you wanted to. And so you can create folders that way. You can upload documents, so you'll just click the upload button, choose files, and you can grab the parts from your J drive if you're here at BYU. If you're at another school, you can grab the file from wherever it is that you've got it saved. So I can go here to my J drive, and I can go to my ME471, and let's see, I believe I've got a Catia part here. I've got a surface model here. So we'll upload my car surface model. So I can hit start upload, and it will upload it to here, and it'll pop up inside this folder. Or, sorry, it'll pop up in the folder that I uploaded it to. Let me go back here. Let's see, there it is right there. So I can click on that, and I can do move, and I can move it to the Catia's Awesome folder. And so now it's inside the Catia's Awesome folder. So that is now on the internet. I can access it from anywhere, and so this is a great way for you guys to share files. If you guys want to create a shared folder so that you can access all of the same parts from a common place, you can do invite to folder, and you can just type in the you can type in the collaborators that you want. So I have another email address, winnx@gmail.com. So I can type in a little message like, hey, share this folder with me. And click share folder, and it will send out an email to that user, and then that user can access that folder from their Dropbox. So it's kind of got a shared Dropbox for separate accounts. So it's a great way to share files and things like that. If I want to download the part and make modifications, all I have to do is click on the part, and it should automatically ask if I want to save it or not. So I can save it to my local computer, open it up in Catia, make my changes, save it, re-upload it, and when I re-upload it, all I have to do is right-click, and there's a previous versions option, and if I go to that, it will show every time I have uploaded a new version of that part, and it will show when it was changed. I can see a preview of it if it has the software capabilities to actually open it. So like it can open Word documents and things like that. But since Catia is not installed locally on this computer, it won't let me. It'll say the size, it'll say who last changed it from the group folder. So I've made this last change here.
Do those changes only show if they've changed it or if they've opened it?
If they've changed it. So you can actually open both, and it'll show what the changes were. So if I go back to my main Dropbox folder, Catia Connect is the multi-user Catia package that we're developing here at BYU. And I am sharing this folder